This is lesson 4-4, solving multi-step inequalities. To solve an inequality involving more than one step, you're going to do the similar process that you did when solving an equation using more than one step. You're going to undo addition and subtraction first, and undo multiplication and division second. Do be aware that before you can undo any addition and subtraction, you must get rid of all parentheses and do all of those things as well. Let's take a look at this first inequality. Negative 3x minus 4 is less than or equal to 14. So the first thing I have to do is I have to get rid of any addition or subtraction. I can clearly see that my inequality has 4 subtracted from it, so I need to add 4 to both sides of the inequality first. If I do that, I now have negative 3x is less than or equal to 18. Now I need to undo any multiplication or division. In this case, they multiplied x by negative 3, so I need to divide by negative 3. Since I divided by a negative number, my inequality must reverse. So now instead of less than or equal to, it becomes greater than or equal to negative 6. So if I'm going to graph this, I simply need to have an inequality here. It's going to be a closed circle at negative 6, and it's going to go to the right because it's greater than. Number 2 says 5 is greater than 7 minus 2h. If I look at this, I have a negative 2h, but the 7 is positive, so what I need to do is get rid of that positive 7 by subtracting 7. Don't think that you need to add 7 because of this negative sign. This negative sign goes with the 2h. So if I subtract 7 from one side, I need to subtract 7 from the other side. These two cancel out. 5 minus 7 is negative 2, is greater than negative 2h. Divide both sides by negative 2 to get h all by itself. Negative 2 divided by negative 2 is positive 1. I divided by a negative number, so I must reverse my inequality symbol. So now it's going to be 1 is less than h, or h is greater than 1. So if I'm going to graph this, h is greater than 1, open circle at 1 with a line going to the right. Number 3 here, negative 8 is less than 5n minus 23, 5n minus 23. They subtracted 23, so I will add 23 because we always get rid of addition and subtraction first. Negative 8 plus 23 is going to give me 15. So I have 15 is less than 5n because these two 23's cancel out. Divide by 5. 15 divided by 5 is 3. 3 is less than n, or n is greater than 3. Open circle at 3 with a line going to the right. In problem number 4, before we can get rid of any addition or subtraction, we must get rid of the distribution. We have to get rid of the parentheses. We have to distribute the 4 throughout the parentheses. So we will have 3x plus 4 times 6 is 24. 4 times negative x is negative 4x, and then less than 2. Now, before I get rid of any addition or subtraction, I need to make sure I have any like terms. I have a 3x here and a negative 4x. They're both on the same side of the inequality symbol, so I must combine these first. 3x minus 4x gives me negative x plus 24 is less than 2. Now I can get rid of any addition or subtraction, which in this case is 24. So I will subtract 24 from both sides of the inequality. And I get negative x is less than negative 22. But I do not want to know what negative x is equal to. I need to know what positive x is equal to. So I will divide by negative 1, because that will give me a positive x, because this is the same thing as saying negative 1x here. Negative 1 divided by negative 1 is positive 1x. But since I divided by a negative number, I must reverse my inequality symbol. And negative 22 divided by negative 1 is positive 22. So x is greater than 22. I'm not going to graph these from this point forward, but if I needed to, the easiest way to do this would be, okay, if here this is 0, this is 22, greater than 22. You don't have to do all the numbers in between. Just make it somewhat reasonable. I know that this is 0 and this is 22, and that looks like a reasonable graph. I'm not going to continue graphing from here on out. 5 and 6 I'm going to do without graphing. Number 5 says 8z minus 6 is less than 3z plus 12. Before I can get rid of addition and subtraction, I need to get all my variables on one side of the inequality or the other. So I'm going to subtract 3z from the left side and subtract 3z from the right side as well. Get rid of those. 8z minus 3z is 5z. Minus 6 is less than 12. Now I need to get rid of the subtraction of 6 by adding 6 to both sides of the inequality. And 5z is less than 18, which is not going to be a whole number answer. Divide by 5, divide by 5. Z is going to be less than 18 divided by 5 is 3. 3 times 5 is 15, and 3/5 left over. Or you could say z is less than 3.3/5 is 6, 3.6. You could be able to graph this just as easily as you could graph whole numbers. Just make sure that you leave a fractional part to it. Number 6, we have to do an awful lot of distributing before we get done. So I'm going to take and distribute my 5 into my -3 and my d, and I'm going to get -15 plus 5d. And then I have to do this again over here. Is less than or equal to 3 times 3d is 9d, and 3 times -2 is -6. Again, I have variables on both sides of the inequality. I prefer to keep my variable on the left side, so I'm going to subtract 9d from the right side and subtract 9d from the right side, leaving me with -15 minus 4d, because 5d minus 9d is -4. These will cancel out, and that's less than or equal to -6. To get d by itself, I first have to add 15. -15, positive 15 cancels out. I get -4d is less than or equal to -6 plus 15 is +9. Now all I need to do is divide by -4 to get d by itself. The 4's cancel out, so d is greater than or equal to, since we divided by a negative number, -9/4, so I could leave it like that, or I could say d is greater than or equal to, 4 goes into 9 twice, -2 and 1/4, or you can use the equivalent decimal, -2.25. Any one of those answers will work. Besides regular problems, we need to also be able to do word problems. The bank is making a rectangular banner that is 20 feet long with trim around the edges. What are the possible widths of the banner if there is no more than 48 feet of trim? Well, it might be a good idea to draw a picture here. So if I have a rectangular banner, my banner looks something like this. It is 20 feet long, so there's 20 feet here, and there's 20 feet here. If I'm going to trim along the outside edge, think of it as being that I'm going to trim along all these edges here. So I need to put trim along those edges. I need to know the possible width, so I'm going to let W equal width. I do know that I have 48 feet of trim, which means that's the perimeter that I can use. I have no more than 48 feet of trim to use to go along the entire outside of my perimeter here. So I know if this is W here, this is also W here. Perimeter is 2 lengths plus 2 widths. Remember, perimeter equals 2 lengths plus 2 widths. If my perimeter is 48 feet and there's no more than that, okay, so my 2 lengths, which is 2 times 20, plus my 2 widths, 2 times W, has got to be less than or equal to 48 feet, because I only have 48 feet of trim that I can use. I have to use 48 feet or less of trim. So now I simply solve this inequality. 2 times 20 is 40, plus 2W is less than or equal to 48. Subtract 40 from both sides. I will have 2w is less than or equal to 8. Divide by 2. So w is less than or equal to 4. So what are the possible widths? My width can be 4 feet or less. So those are all my possible widths, 4 feet or less. So 3.99 feet, 3.98 feet, 3.9 feet, 3.87 feet. Any of those would work. So anything 4 feet or less would work. Last word problem. Suppose it costs $5 to enter a carnival. Each ride costs $1.25. You have $15 to spend at the carnival. What is the greatest number of rides that you can go on? Obviously, again, we have to define our variable, and it's asking what is the greatest number of rides. So I'm going to let R equal number of rides. So it costs $5 to enter, and rides cost $1.25. So my entry fee plus my cost of the rides, and I have $15, so it has to be less than or equal to $15. And what I pay to get in plus my cost of my rides has got to be less than or equal to $15. So it costs $5 to get in, plus the cost of the rides is $1.25 times the number of rides, which I don't know how many rides I'm going to take, so I'm going to make that n. So that's got to be less than or equal to 15. My entry fee plus all my cost of my rides, which is the number of rides times the cost of each ride, it's got to be less than or equal to 15. So here I will subtract 5 from both sides. So 1.25n is less than or equal to 10. Divide by 1.25. N is less than or equal to 8. So what is the greatest number of rides that you can go on? You can go on at most 8 rides. And that's basically solving multi-step inequalities.